Hello everyone and welcome back to Geotech Masters. In our last episode, we measured the geometry of rock. We learned how to measure depth and depth direction to tell us where the fractures are in space. But knowing the angle is only half the battle. Today we are going to look inside the cracks. We are going to examine the surface texture, the gap between the walls, and the material filling the gap. Why does this matter? Because a rough, tight joint is very strong, but a smooth, clay-filled joint is like a greased slide. Understanding these details, roughness, aperture, infilling, and seepage, is the key to predict if a rock slope will stand up or slide down. Let's get to work.
Before we start describing, let's think about the engineering problems we are solving. First, have you ever heard someone describe a rock surface as wavy? Is that the same as rough? In the ISO standard, these words mean different things at different scales. We will clarify this today. Second, does the width of the crack, the aperture, matter if there is nothing inside it? Is a 1 millimeter gap safer than a 10 millimeter gap? And finally, how does water play a role? We know water is the enemy of stability, but how do we record it systematically on a log? We will answer all these questions in this session. Let's start with roughness. The standard requires us to look at roughness at 3 different scales. This is a very important concept. First, the small scale. This is what you see in a few millimeters. It is what you feel with your finger. Is it like sandpaper or is it like glass? Second, the medium scale. This is what you see over several centimeters, like the length of a core sample. Is the surface flat or does it have steps? Third, the large scale. This is what you see over several meters on a tunnel wall or cliff face. Is the whole crack straight or is it curved? You need to describe all 3 to give the full picture. The standard gives us specific terms to use in Table 12.